Hello and welcome to the fourth video in this series going through the May 2015 Core 2 paper. So this is question 4 and it shows the sketch of a scraper blade. The blade AOBCDA consists of an isosceles triangle in the middle, and then it has two sectors of a circle with a radius of 8 centimeters. Angle AOD, so that's this one in this corner, and BOC are equal. So basically these two sectors are exactly the same, with an isosceles triangle in the middle. AOB is a straight line, so across there is a kind of like a diameter, and is parallel to the line DC. DC has a length of 7 as labelled. So part 1 is to show that angle COD is 0.906 radians. So we need to make sure we give our answer in radians, make sure our calculator is in radians, and correct to 3 significant figures. So this one, we're looking at the angle in the bottom here. So we should kind of spot already that we've got the long side over here, this side of the triangle, and we also actually know what these ones are, because these are both a radius of the sector. So we know this length along the bottom is 8, so that means that this one must also be 8, and this one must be 8. So if we know 3 sides, you should already be thinking in your head, well, 3 sides of a non-right angled triangle, that means I'm going to use the cosine rule. And since we're looking for an angle, we're going to use the version of the cosine rule that is cos of A is equal to B squared plus C squared minus A squared all over 2BC. Because we're looking for an angle, we're going to use this version of the cosine rule. So a good first step is always to label up the sides. So I'm going to call this angle down here my capital A, that's the one I'm looking for, which means the opposite side is lowercase a, and then it doesn't matter here which way I label these, I can call them either way, but I'm going to do it B and C here. So we've got 8 centimeters for C and B, and A is 7. So we just substitute that into our equation. So cos of A is equal to B is 8, so it's 8 squared plus if I can make it work, there we go. 8 squared plus 8 squared minus 7 squared for A all over 2 times 8 times 8, because B is 8 and C is 8. So if we have that, that means I can find the inverse cos, so cos to the minus 1 of all of that, and that will give me my angle A. So just type in that. Into your calculators, as I said earlier, make sure you are in radians, otherwise you're going to get the wrong answer. And if you type that into your calculator, you will get 0.906, correct to 3 decimal places. So we have done part A. So part B says to find the perimeter, so the distance around the outside, of our scraper blade. So we already know this length along the bottom is 16, and we already know the length along the top is 7. So the only bits that we're not sure about are these lengths here. So these two are the same because the angles are the same and they're both part of the same circle with the same angle. And these are the arc length of these sectors. So we're going to need to use the arc length formula, which is L is equal to the radius times the angle theta. So for this one, the length is going to be equal to the radius, which is 8, multiplied by the angle here. Now this bit we aren't sure of yet, but we do know that angles on a straight line in radians add to pi. So if I wanted to find this missing angle here, I'm going to need to do pi, subtract my angle from earlier, so 0.906. And since these two are the same, if I divide that answer by 2, that will give me the size of one of the angles. So type into your calculator, or if you're pretty good with mental maths, you will find that is 1.12. So this angle down here is 1.12. Okay, so that means we can go back to this formula. So the length is going to be equal to, the arc length is going to be equal to 8 multiplied by 1.12, and that gives you an answer of 8.96. So that means our total perimeter, so I call that P, is equal to 16 plus 7 plus 2 lots of 8.96, since we have the two arc lengths here and here. Okay, and again, since it's core 2, we can just type that into our calculators and get the perimeter will be 40.92. And then again, this wants to be rounded to 3 significant figures, so 40.9 centimetres, since it's a length, centimetres. There we go. So just the last part to do now. So this one says to find the area of AOBCDA. So for this one, we have a triangle and we have the two sectors. So if we start off finding the area of a triangle, area of the triangle. So it's a non-right angled triangle, but we do know these sides. So this one, remember, is 8 and 8, and we know the angle is 0.906. So we know the angle, we know the 3 sides. In fact, we don't need all 3 sides because we can just use our sine formula for the area of a triangle. So the area is equal to half AB sine C. So this is our A, this is our B, and then our capital C is the angle down here. So to find the area, we do a half times by A, which in this case is 8, times by B, which again is 8, multiplied by sine of the angle. So sine of 0.906. So that will give us an area for the triangle of 25.1854. So the area of the triangle, 25.1854. So that's only the area of the triangle. We're also going to need the area of these two sectors. So to find the area of the sector, area of the sector, okay, I'm going to need to use the area of the sector formula. So we should hopefully remember that one is the angle theta over 2 multiplied by r squared when we're in radians. Let's try and draw that a bit better. There we go. So we already know from earlier that this angle here is going to be, draw that on, 1.12. We found that in part B. So we know that. We know the radius is also 8 because it's half of 16. So we're going to do 1.12 over 2 multiplied by the 8 squared for the area of one of the sectors. If we do that, we will get 35.84. Okay, so we are nearly there then. So we've got the area of the triangle is 25.185 4, and then we have two sectors, because in our diagram we've got two of the same sector. So we've got two lots of 35.84. And again, type that into our calculators and we will get 96.8654. And again, for this question, they asked for it to three significant figures, so it'll be 96.9 centimeters squared this time because we have an area. So that was question 4. Just really using the sine and cosine rule, just the cosine rule, and then just finding the arc length and the area of a sector. And just making sure you're in radians is one of the common mistakes, and also just being careful to label the sides appropriately where you need to, and then just rounding through significant figures. Hopefully that was helpful, but if you have any questions, please leave them in the comments.